Hi guys, welcome back to Math for Teachers 2. Today we are going to do Module 1 lesson. So let's go ahead and get in. So for question 1, we are asked to draw a graph for 4 different scenarios and explain why our graph corresponds with each scenario. So here are my 4 graphs that I drew. The first graph that I drew right here, part A, correlates to the function of the amount of gas in a tank when a driver refills the tank on a drive across the country. And as you can see, X is increasing right here, while Y is decreasing, which means that the further he drives, the more gas he uses. And when Y is increasing right here, that means, or this is when he is filling up his gas tank, and then he is driving again right here. For B, I drew a graph that correlates to the function of the height of an elevator stopping at each floor on the way up. And as you can see, Y increasing represents the elevator going up to the next floor, and when it's staying the same and X starts to increase, that means that the elevator is stopped on this floor, and it goes up and stops until it gets all the way to the top. For C, I drew a graph to correlate with the function of the length of a shadow of a flagpole throughout a sunny day. And as you can see, at the beginning of the day, the shadow is long, and then as the day gets, the flagpole shadow starts to get shorter as the day goes on, and then as the sun starts to set, the flagpole shadow actually gets longer again. And for D, I drew a graph to correlate with the function of the height of a bouncing ball dropping from a table. And you can kind of see right here is where the ball is dropped from the table, and then it goes down and then up, and as the ball is bouncing, it gets shorter and shorter. Now for question 2. So for question 2, we are using function machines. Suppose 2 function machines are hooked up in a sequence, so the output chute of machine G empties into the input hopper of machine F. There are rules that the function machine has that we have to follow, which are multiplying by 3 and then adding by 8, as you can see right here. We have to input X into our function to get our output Y. For example, in part A, we input 0 in for X, which equals 0. And then 0 plus 8 equals 8. And for B, we input 1, so 3 times 1 equals 3. 3 times 1 plus 8 equals 11. And for C, we input 2 for X, so 3 times 2 equals 6. And 3 times 2 plus 8 equals 14. And for D, we input 3. 3 times 3 is 9. And 3 times 3 plus 8 equals 17. Now let's go to question 3. So for question 3, we have to find the slope of the line that is passing through 2 points. To do this, we have to use point-slope formula in parts A through C right here. So point-slope formula is y2 minus y1 over x2 minus x1. We can also check to see if we got the correct slope by counting down our line. So for example, with A, after we do point-slope formula, we get 2 as our slope. And we can also check this by counting down from this endpoint, our 5, 5. We can go 1, 2 over 1, 1, 2 over 1. So that means that our slope of 2 is correct. And for B, our slope is 0. And as you can see on our graph right here, that our slope is 0, that our segment is vertical. Now for question 4. So for question 4, we have to graph each of the following functions and describe the similarities, differences, and relationships between the graphs. The first thing I did was create a table of values for each function, as you can see right here. And then I picked a few numbers for x. I picked -2 through +2 for each of my functions. After I plugged in these numbers for x and got my output y, I used these numbers to plot my points on my graph. And after I plotted my points, I drew my line connecting all the points. And as you can see, all three of the graphs are similar because they are vertical shifts of the exact same curve, as you can see right here. This is my function y equals x2 plus 7 right here. And this is y equals x2. And this is y equals x2 minus 7. And they are all vertical shifts of the exact same curve. Now for question 5. For question 5, we have to show and explain the equation of the line through the given point that is perpendicular to the given line. So, the first thing that I did was find the negative reciprocal of the slope. So, to find the negative reciprocal of our slope, we take our slope, which is -3 over 4x right here, and we change the sign. So we would change this sign to a positive, and we flip our numerator and our denominator. So our new slope is 4/3. The next thing we do is we are going to use point slope formula like we did for question 3, I believe, to find our equation of the line. So here's our point slope formula again. And we are going to plug in our points. So our equation of the line for this problem would be y equals 4/3x minus 9. And we do the same thing for part B as we did for A. To find our reciprocal, the slope of the line perpendicular to the given line, we would switch our slope that we found, and it would be 2/9. Thank you, guys.